Today we are taking a look at these three cool contenders: the Bambu Lab Cool Plate, SuperTack and the BQ Panda CryoGrip Pro Frostbite. That's quite a mouthful. These blue plates have generated a lot of hype and I will be putting them through their paces. We will run the classic Pisa tower test, design a custom rig to test adhesion in lateral and vertical direction, assess the surface finish of the first layer and discuss the durability of the plates. By the end of the video, we'll rate these plates by category and declare a winner. Let's see how they stack up and which one I'd recommend for your 3D printing needs. Every 3D print starts with the first layer, and getting that first layer to stick is critical. Poor adhesion is one of the leading causes for failed prints, second only to wet filament, which by the way we'll cover in an upcoming video. To achieve a successful first layer, 3D printers rely on various types of print beds. Most are heated to improve adhesion. But for PLA, Bambu Lab introduced a cool plate, a built surface designed to work without heat. It's meant to save energy, speed up the printing process since you can skip the warm arm phase, and simplify PLA and PETG printing. Initially, the cool plate worked well, but its soft surface was prone to damage and tricky to clean. Just before the announcement of the success of the cool plate, BQ entered the scene with their CryoGrip series, including the Frostbite and the Glacier plate. While the Frostbite is a cool plate with rough texture, the Glacier should be run at higher temperatures and is compatible with more material types. But our focus today are the cool plates. Therefore asking two major questions. One, is the SuperTack a worthy successor of the cool plate? And two, is the CryoGrip Frostbite worth the hype? And how does it compare? Let's start with price. All three plates are similar priced, hovering around $30. To ensure a fair comparison, I conducted all tests at 35 degrees Celsius. The SuperTack is recommended to be used at 45, but let's face it, if a plate needs to be heated to 45 for PLA, can it still be called a cold plate? The first test I conducted is the classic Pisa tower. The standard tower model wasn't quite challenging enough, so I designed my own version to push the limits. It starts with a tiny surface area at the bottom and extends to the maximum build volume of my Bambu Lab X1 carbon. After slicing the model, I hit print. All three towers are ran on the same machine and with the exact same G-code to ensure a level playing field. Surprisingly, all three towers printed successfully without detaching, but there were differences. The cool plate had a mist layer and some filament stringing at the top of the tower. In the time lapse, you can see the tower move slightly, causing the nozzle to skip a line. The SuperTack performed better, but still had 3 or 4 spots where overhangs didn't print smoothly. Then there's Frostbite, which handled the print like a champ. No missed layers, no overhang issues, just some small defects at the seam. Time to distribute the points. Frostbite gets 3, SuperTack 2 and the cool plates gets 1 for trying. While the Pisa tower test is qualitative, I wanted hard numbers. To measure adhesion quantitatively, we have to build a test rig to assess the shear and vertical forces needed to break adhesion. Shear forces are particularly important because lateral nozzle movements during printing can cause parts with small surface areas to detach. Vertical forces are less critical, but during Z-hops they can still lead to detachment. The idea is to have a loop printed on the build plate, which has 2 corners where we can hang weights to test the adhesion in 2 directions. Thankfully I have some bearings laying around from an old project. Each has a weight of 34 grams and will do the trick. Let's hop into Fusion again to design the simple rig. The loop has a base surface of 25 by 25 mm. We then draw the basic shape of a rectangle sitting on a stick and use the thin extrude to create the body. Of course we need 2 to test both directions, so we slice 2 of them and print it on all plates. Now we just need a holder for all these bearings. Bear with me here. Let's first create a tube that would fit 20 bearings in. Then we do a wavy cutout so that we can put the bearings in one by one. If we would drop them from above, it would falsify the results due to the dynamic forces. Now we add a hook onto it to fit into our loop. Last step is to round all edges for more stability, and 1.5 hours and 50 grams of filament later we can start the test. I've mounted the plate on the wall and now I can add the bearing at a time. Okay, that was unexpected. 730 grams is definitely not enough. There's no movement at all. Back to the drawing board. Let's add more cylinders then. 2 more? Just to be sure we add 4 more. That would be a total weight of more than 3.5 kilograms. That should do the trick, hopefully. The holder itself is now 200 grams. Here we go again. Oof, and I thought it would never fail. So the cool plate failed at 2.58 kilograms. I'm not sure what is more impressive, the adhesion of the cool plate or that the hook or the loop didn't break before. Let's see how the other two plates perform. The SuperTack failed already at 1.66 kilograms and the Frostbite failed at 1.97 kilograms. That makes the cool plate the clear winner in lateral adhesion, followed by the Frostbite and then SuperTack. If we add up the points, we have now 5 for the Frostbite, 4 for the cool plate and 3 for the SuperTack. For the vertical adhesion test, I suspended the plates between two tables to eliminate bending effects. As expected, vertical adhesion was much stronger. Even at full capacity and therefore 3.6 kilograms, there's no sign of detachment at all. And all 3 plates handled the maximum load without even flinching. If we go back to the scoreboard, we can see that the rankings of course still the same, with the scores being shifted by 3 points. One of my Patreon supporters specifically requested the next test: surface quality, which is an important factor for many users. Bambu Lab advertises their plates as producing smooth, matte bottom layers nearly indistinguishable from the top layer. After peeling the loops off the plates, here's what I observed. The cool plate delivered a smooth matte finish that looked excellent. The SuperTack was similar but had a slightly rougher texture, adding a subtle grain to the surface. And then there's Frostbite with its shiny and textured finish, similar to the textured Bambu Lab plate. We give 3 points each to the cool plate and the SuperTack and 2 to Frostbite. As you can see, it's a very close one, with Frostbite and cool plate leading with 10 points and SuperTack following with 9. Let's move on to durability. Over time, build plates wear out and their performance degrade. The cool plate, with its softer surface, is more likely to wear down faster than the SuperTack or Frostbite. At least we know that already from experience. How well the new cool plates are doing will be a subject to a future video. As for now, we give the cool plate 2 points and the other 2 each 3. And we have our winner. Frostbite wins with 13 points, just 1 point ahead of the other 2 bamboo plates. But should you get the Frostbite? It's not that simple. Let's interpret the results since it was such a close one. The first question we wanted to answer was if the SuperTack was a worthy upgrade to the cool plate. Their focus was clearly to make the plate more long-lived, but they had to compromise on the adhesion as we saw in the test. At 35 degrees Celsius, the cool plate outperforms the SuperTack. That might be also the main reason why Bambu Lab increased the plate temperature to 45 degrees Celsius. With the adhesion and surface finish being similar, and if we put the longevity of the SuperTack on top, it's clearly a worthy successor. The second question was if the CryoGrip Frostbite is worth the hype. The plate has great adhesion and showed the best results in the Pisa tower test. If you don't care about the surface finish or like a shiny bottom layer, then the Frostbite is a better choice than the SuperTack. However, if you don't care about the energy costs or want to have a matte bottom layer, then SuperTack is your plate of choice. The link of each of these plates are in the description below. But wait, the Frostbite also has its older brother, the Glacier, which has a more matte finish. But then we're moving out of the cool plate regime and I might do a future video comparing more plates with different materials. If you want to see more of these videos, hit the like button and subscribe, or become a Patreon where you can vote on upcoming topics, participate in giveaways and soon learn CAD with weekly challenges. So don't miss out on that. Until then, happy printing, 3D farmers!